Hello, welcome to Python for Beginners from our 365 Academy. Today, the 20th of December, 2020. We will be discussing interactively with Python, and we have had a couple of series before now, and today is our fourth meeting. With me is Joseph Itopa, who is a lead machine learning engineer and has done a couple of projects with Omdina. He has also participated with some projects with Array365. So he will start and I will be here to interject and interact together as we proceed in learning data sciences for artificial intelligence. So Joseph, if you're ready, you can just share your screen and continue from where we stopped the last time.
Okay, thank you, Ademola. Thanks for the introduction. So, before we begin, this is the fourth series of the six webinar series we have for Python for Beginners, and the objective is very clear. We are driving you towards a particular point, which is to make you a data scientist, and we just don't want to do that. We want to give you some foundations that you will understand, or that will help you to understand the programming language you will definitely adopt in learning data science. So I will share my screen right away. Okay, you have to
Okay. Are you able to share?
No, not yet.
Okay, what about now?
Yeah, I can share right now. So just let me know when if you can see my screen.
Yes.
Okay, can you see my screen?
Yes.
Okay. Anyways, so the first thing we do is to go on Google and just type Google Colab, and there it is. We'll just go ahead, click on the Google Colab, the first one here, and the link to the code will be shared with you on the chat section and also through YouTube. But then you click on GitHub. So it's trying to authenticate my account. Okay, then you just simply paste the link, the GitHub link to the notebook, to the Python notebook. And you click on search. So it's trying to load the page. Okay. We had one exercise that should be done, and 2 weeks was given so that you can take your time and do it. It's not quite difficult. Basically, what we are expected to do is to read letters or words and also numbers and generate the Morse code equivalent. That was the exercise. It's not difficult, and we have this table to guide us. So the first thing we do is to use a dictionary, because dictionary has keys, and the Morse code, the letters, the numbers are the keys, and the Morse code are the value. So we use the key to access the values. And under data structure, we've talked about this past few weeks on how to, on dealing with them, tuples, dictionary, and list. So we just arrange the letters as key and the numbers as well. Then we put the Morse code equivalent as the value. That's what you see here. Then of course you shouldn't forget to separate them with a comma. So after that, we have this simple, in this exercise, we try to make it as simple as possible for you to understand. Ideally, we're supposed to use functions or classes to handle it, to make it more, will I say more?
Sorry, Joseph, can I interrupt you a little bit?
No, go ahead, go ahead.
I just want to share my screen for a moment.
Okay.
But you don't need to take any action, I guess. Okay. So you're talking about Morse code, right?
Yes.
Yeah, so a lot of people might not know what the definition of Morse code is. I just had to quickly check too, and why it is important. So Morse code is a method used in telecommunication to encode text characters as standardized sequences of two different signal durations called dots and dashes. So the essence of Morse code, or the fundamentals, are dots and dashes, and how it can be represented in a standardized fashion. And it was invented by mathematicians and based on Arabic numerals. Okay, you can continue.
All right, thank you for that. And in addition to that, I think Morse code was very useful during the World War. Yeah, for encryption and for message transmission, basically. So we had this very dictionary that contains the keys and the equivalent value for each of those keys. So we had this exercise. We tried to solve it. We have to take input according to the exercise. We must take input, and for each of those inputs, we'll have to generate the Morse code equivalent of it. However, we can actually handle this using methods and methods or functions and classes. But then we have to keep it very simple for our students to understand this, since we have not taken them deeply into classes, though we have introduced you to, or we've introduced them to methods, functions, that's about 2 weeks ago. So here we just basically we output this statement that, okay, if you want to enter number, type yes. If you want to enter string, type no. Then for us to be able to ensure that what you type in matches the conditions we've set here, we use the method, it's a function, .upper, to convert your answer in case your answer is in lowercase or your answer is in a combination of lowercase and uppercase. We just convert it to uppercase so that it will match with our condition. Then we take the input as a string, we store it here, and then we check what we have stored here. Is it the same with this? If it's the same, then we tell you to enter your input, which should be a digit. And then if you type no, we repeat the same condition, and then we take in your input, which is string. Here should be integer, not string. Okay. Okay. Sorry. So It's still correct. So that's what we basically do. Then if it doesn't fall into any of this, that is if it is neither yes, if it's either yes, if it doesn't fall into yes or no, the best thing we just have to print out is that your decision is not among the available choices. So we'll start this by running that. So run it, and then okay. Okay, it has run. So we'll run this, and okay, let me say yes. So it asked me to enter a digit. I entered 8 and click that. Okay, that's all the particular the cell is to handle. So then I have to execute this particular cell for numbers, but if it's for string, I'll have to come a bit down to execute this. That is where classes are important. I am supposed to just invoke the class or a function, invoke them to do the job. But then to keep it simple for you to understand so that we don't start taking you to where you have not gotten to, let's just execute this. Later on, you understand how they should be. Then we're now saying that the number we have entered, if it's inside, if it's one of the keys in the dictionary, we entered 8, right? So we are going to search this dictionary and search for 8. So when we get to 8, if we found 8, which is here, then we print out the equivalent Morse code. That's basically what we are doing. So, and that's what you have here. I kept this in case you want to. I can just take it off. Okay. Again, so you have the equivalent Morse code, triple dash and double dots, which is the same as here. So if we want to try something else with string, first thing is that string, it can be a word, it can be a sentence, whatever it is, we store it as a list. Then what we do now is that in the list, we try to break it into characters. So after breaking it into characters, we now come here and pick each character and then generate the equivalent Morse code. So we are going to try it by starting with this. So I'm just going to say no. So it will ask me to enter a letter or a word. I can say go. I hit this. Okay, it has taken go getter. So I will leave this and come to the string part of it and execute it. So you see it has treated it as a list. It has separated the words into letters, into characters. So then I come here and said generate the Morse code equivalent. You see, there's a particular spot there. For each of the letters, it generates the Morse code equivalent. For we to confirm, G is double dash with a dot. We can just quickly go up and see for ourselves, which is here. You see, you have double dash or hyphen and a dot. So, but one other thing you need to observe is that we did not, in the Morse code, there's no room for empty space. That is why you see here the value is not in the DBase, it's not in the dictionary. So basically that's what the example is all about. To ensure you practice it, you can implement it in so many ways. And of course, I do hope that at the end of this class, you can go back to this example and implement it using functions and classes. So thank you very much for attending today's class or for coming for today's class. We have object-oriented programming. That's what we intend to discuss today. And under object-oriented programming, we'll be talking about what are classes, functional classes, some terminologies you should understand about classes, the fundamental structure of a class. And then we define a class, class intrinsic attributes, comments in classes. Then we'll talk about inheritance. and then multiple inheritance, composition versus inheritance. So all these are not difficult. So by the end of this class, I do believe you understand them better. So introduction to object-oriented programming. A class is the instance of an object. And that raises a question: what is an object? But then you will understand that in every class there is a function, sometimes also called methods. Those are the method in combination with the attribute forms an object. Each one is an object. So by design, or let me say by principle, a class must have at least one object before you can call it a class. So the essence of having classes in programming is that it helps us to create instances, like starting an object. It helps us to be able to utilize or define instance of a method, like we can begin initializing functions in a class. It may sound strange, but do not worry. By the time you look at the example, you will understand better. And definitely I will come back to this definition to make it clearer to you. Then we have the attributes, and which is the data. Yeah, the data. In fact, when you talk about classes, it involves two things: data manipulation, and of course functions that helps you, that holds the behavior, or that holds the how you want the data to be manipulated. Those are the two things that forms a class. And it's actually very important because it helps us to be able to reuse our code. There is what is called code refactoring, and code refactoring is all about you changing the code to maybe more efficient code without actually changing the function the code performs. So, and that is where classes come in. If you have a class and you have which is some set of codes to do a particular thing, you can actually alter it to maybe the code is first, initially it was 20 line of code, and you decide to alter it and you now have 5 lines of code. So and it's still doing the same thing that the 20 line of code is doing. That is code refactoring. And it's very important in classes because there are most times you reuse classes. You have a class defined to perform a particular function, and you have to use these classes in so many places. So you don't want to start causing problems. So you have this class, instead of you to be tampering with all your program, you just go to the class and you make those changes, and it takes effect in the entire project. So we'll talk about the terminologies. A class defines the constitution of data and the behavior that function the data. Basically, what it is when you are talking about a class, you have methods, which are functions, and then on the other hand, you have data. So you want this function to be able to manipulate this data. So those two things, when you put them together, it forms a class. So an object or an instance is a sample of a class, an example of a class. We are saying class at the very basic level. Okay, let's take it to a particular group of gathering. Let's say student class, for instance. Let's take it. For you to call a particular or an auditorium, for it to be regarded as an auditorium, students definitely will have to sit there to receive lecture. And then without that, the purpose is not achieved. So when you have one student in such an auditorium, you can still refer to it as an auditorium. When you have many students in it, you can refer to it as an auditorium. But when you're now having animals in it, like goats, donkeys, of course, the very purpose with which the auditorium is designed for has not been achieved. So it becomes something else. Then a method is a function, and we've talked about it in our previous class, so don't be lost about it. They are just functions. Just used a method called .upper. It's a function. Someone wrote the code, package it, upload it, and then I can use it, you can use it, any other person can use it. All I just need to do is what? Invoke it, and it works. We have attributes. Hello?
Yeah, for a beginner, what is the first example that can be remembered in a combination, like making a class? For example, a class can be viewed as you have said, like a collection or meeting when some certain properties are met, then they fit into a class. And those properties now are the functions that can be configured based on accepting input and returning, having a return value for the function.
So and the question you're asking now is that I should give a practical example of a class, right? Or
maybe in relation to food, or in relation to I think you give animals, but in relation to food, or maybe an application that a programmer can be interested in, because we have people who do sorting.
Okay. Here is the explanation I think I can give to that. Imagine you having a room. In this room, you have several stuff in it. You have fans, you have your bed, you have so many things in it. Now, having all those things, we can regard that room as a class. However, we can also say that if that room has one thing, maybe a chair, maybe a table, then it can also be regarded as what? A class. It must have a thing to define it as a class. A class cannot be empty. So that is where an object comes in. The object we are talking about can be the chair in the room, it can be the table, it can be your bed. So whenever we have one of those,
so the first
in the room, you can regard it as an instance of a class.
The class cannot be empty. That's the first thing that should be understood about classes.
So, and we'll talk about the structure of a class, but then we have method, which are functions. We have messages. Of course, when you define a class, it is not defined to just stay there and do nothing. It is defined for a purpose, and you definitely send message to it, and the class will return a response to you. So, for instance, the structure of a class here. First, we use the keyword class. This keyword is what Python used to know that, okay, what you are doing at this particular part of the code or this chunk of code is a class. Then you have the name of the class that will be defined. That is what you use to invoke it whenever you want to make use of the class. And then there is a method, otherwise you refer to it as a constructor, which is the init method here. It is very important because in every class, you must have an init method to initialize the class. Then sometimes a class has parameters, sometimes it is empty. That's where you have the superclass. We now have our attributes and methods. Attributes are the data, do not forget, and the methods are the functions in the class. So I think it's time for we to look at example, because it's somehow you may not find it easy to understand without example. We have a class person in this place, and we have a constructor. And then in this constructor, we have some parameter, self, name, and age. And our most concern here is the name and age. The self is very important. It's what you use to connect to the other parameters, which is this. However, to make references is the dot notation is very important in Python. In fact, there's no other notation that is used except the dot notation for making reference to a particular attribute or method. So what you have here, we have this class, which is very important because Python needs to know whether it's a class. If it is a function, then you have what? The def. So don't confuse the two of them. There's def, there is class. Yeah, hello?
Def for definition.
Yeah, def for definition, and class you have there to identify that it's a class. So in this case, we have to make reference to the attributes, the name and the age. So we point to them, and whenever we call this class, this is where we send data to, and we can make reference to it. So for we to now make use of the class, we have an instance of a class. This is an object. This is an object. What makes it an object? It has what? An attribute in it, and it's going to be making use of a function, which is the def here, to store the data, which are the attributes. So we'll run this. You see nothing. So we come here, we now said, okay, person, the person is Mike. We have the name and the age. So we run the object. This is an object. We can have varieties of this one. Then you can see we also have other types here, John. We can have Phoebe. So we do this and it stores. Then we can make reference to them. So when we call them, we know their location. If you check this address, these are the memory, this is addressed to the memory location where the data is stored. So you can see that they are all the same except the last four, I call them alphanumeric characters. They are what? These are the differences to tell you that they are stored in different locations. So, and it's telling us that it is an object. Each of them is an object. And we can also print them. We can output what is stored in each one, everything that has been stored in the class. So we can just simply come here and say print Mike name, print the name. We can also say print the age and run it. We print the age. So by so doing, this is how we access the objects in a class. It's very basic and it may seem not too friendly to you the first time, but you have to review it again. And I'm very sure it's going to be important because the heart of all development is object-oriented programming. So we can call them, we can call multiple of them at the same time. It's not just one. You can call the name and the age. So when we do that, see John is 36. So this is one of the importance of classes. So we've looked at our first example, how we define them, how we have structured to initialize it, and our attribute. So after that, we'll talk about class intrinsic attributes. Well, there are two intrinsic attributes, class attributes and object attributes. What we are basically talking about here is that there are some predefined classes in Python. All you just need to do is invoke them and use them. So in this case, they are classified into two. We have the class attribute and we have the object attribute, meaning we have the ones we can use with objects and we have the other ones we can use with classes only, but not with objects. So, and here is a list, a basic list of the ones. We can make use of the name, which is the name of the class. What this does is to print the name of the class. And this also helps us to get the library from which the class is loaded. We can also have the basis, a collection of its base classes, dictionary. So we'll play with some of them as we go along so that it can be very easy for us. Let's say we have a class founder. It's a very basic class. And in this class, we have a constructor, which is also a function. We initialize it. It's going to be storing name and gender, and then it will store them here and there. So let's run it. Then we can now pass our data to it. We can through messaging. So we send a message to the class, and the class saves the data. So this is an object. Don't forget, whenever you are sending, this is the class founder. So you come here, you declare the founder, and then in it, you pass in your variables. And those variables you pass in is what the class we put in here. You may be asking what happens to self. Do not forget, self is simply going to what we use to connect to the name and the gender to collect those data. So it's not a variable, it's a special attribute on its own. We need it in every Python classes. It's very important. So run this, then
I think self holds the properties, the information that calls it a class, and what a class can do.
Come again, is it a question or an opinion?
Just a thought.
Okay. No, go ahead, please repeat it, let me understand.
Self. The essence of self is to identify the class as a class, or to give it an extra property.
Yes, because the truth is this. I agree with you. However, the truth is that when you define a class, the class needs to get connected to the attributes of the method in it. This is a method in a class, and this is the class that has been defined. So in this class, we have this method, and then this class, we want to be able to relate with the attributes in the method, and that is where self comes in. With the help of self, the class will be able to relate with the attributes in the method. So now we can play with some of the predefined model. And do not forget, you see this, that is two double underscore. You have them before and after, and they are very important. You can't use one of them. So, and the reason why you can't do that is because it is standardized for Python. We can apply the name. The name will help us to print the name of the class founder. Then the module will help us to print the module in the class, which is main. Then the documentation, there is no documentation, so it's going to give you none. So those are how you can use the classes, but then it's just for you to know it's important. You don't really need that for now. And then the objects. So the intrinsic attribute for object, you have a class which tells you the name of the class founder. And then you have the dict. It's trying to, this one will tell you the data stored in the form of a dictionary in the class. So if you have a class and you are running the class, you are making use of it, you can also, at the point you just want to know the object in the class, you can pick a particular object and connect it to dict, and you know what is stored in the object, or what data the object is holding or sending to the class. Then this takes us to commenting classes. We use the double quotes, 6 of them, for commenting classes. And the essence is that you can have multiple classes. You can have lots of them. How do you know which class is which? I mean, I just want to look at your code, and then I don't have to stress myself reading every line trying to understand. Basically, by looking at your code, I should be able to say, okay, this is what this part of the code is doing. So you have to add comments, and in classes you do that using the double quotes, and you have 6 of them. So in between them, you drop your comment. So when you do that, it runs. But there's something I want you to note. We'll be talking about further example here, an interactive example. Before that, we are going to run it to see, okay, we have an error, expected an indented block, and it's pointing at our comment. So do not forget, whenever you have a class, you have to indent it, but I prefer always shifting it such that it's not in the same column as the keyword. So if you run it again, you see that it's fine. So Python doesn't joke with indentation. In this class, we want to play with it and see what is happening. As I said earlier, we can have multiple methods in it. So in this case, we have 2 methods. So the first one, which will help us to handle our attributes or the properties of the object, which is the age and the name. Then the second method now is to help us to identify, to have some little condition, like, okay, if the age is less than 12 years old, we can say, oh, you can call the name and say you are a baby. If the age is greater than 14 or less than 18, we can say you are a teenager. Else, we can just say you are an adult. So you can see that in the class, we can have several methods. So we have one here, and we have the one that handles the data. So having run this, we can come here and said, okay, let us declare our first object and pass in some data. We run it, and it doesn't seem to do anything special now, but we can call one of our functions inside the class. Now this is where the magic is. So you say, Newton, you are an adult, because it's 26, and we have agreed that anything above 18, because we say less than 12 is baby, between 14 and 18 is teenager, then anything else is going to be what? An adult. So this is just an example. Don't think of it as a perfect unit. But then one thing you should understand is that all we need to do is pick the object and then use the dot notation and pick the name of the method that have been declared inside the class. So automatically it executes. We can change this and said, okay, let it be 6, and then we say, okay, this is now okay, newborn. And just change it to something else. We run the same code. We do this. Newborn, you are a baby. You see, so it's very basic and easy to use once you get familiar with it. So we'll talk about inheritance. Class inheritance in Python is a type of object-oriented programming where a class inherits the attributes and method of another class. Yeah.
Can you please explain where the newborn comes in?
Yes, I changed the name here and also the age. So basically, I changed the data that the object is holding. So I change it and then run the code. So the object passed that to the class. And when I call it, when I said, okay, the object, I want the method find age group to use the data that the object has passed to the class. And then give me a result. What does it make of the data? So it comes out with, okay, newborn, you are a baby, meaning it is 6. And we have declared in the find age group, we have declared it that any age, if the age is less than 12, it should be you should print out the name and say you are a baby. So that's why we have this. So I hope it's very clear.
Yes.
Then we have the class inheritance. So inheritance basically is just like the way it happens in families. I mean, my father has a house, I am his son, I want to, by the time he thinks that, okay, maybe he leaves this world, I'll just be like, okay, I am the son, I inherit his property. That's if he will it to me. So in programming, it also happens, especially in object-oriented programming. Sometimes you have this class that you have used in so many places. It's a wonderful work that you've done there. And then you want to define a new class. And you realize that this new class has some features that is very similar to the old class that you define. However, all the features are not the same. It just takes some part of it. Let's say, for instance, let's say animal, or okay, let me say fruits. You have these fruits, and you know different classes of fruits, and then you just say, okay, one thing, the first fruit is mango, and the second fruit is banana. Okay, here's what we'll do. The shape of the mango, the color of the mango, and the quantity is important to me. But the banana, I also have to be considerate of the color. So if the banana and the mango are sharing the same color, which is maybe yellow, I can just say, okay, instead of me to be declaring for a new color on that banana as an object, let me just pick the one that the mango is having, which is yellow. So I just inherit the attitude or the characteristics for the banana. So basically what it does is just, okay, parents, child inherits some attributes from the parent. Then sometimes it can just inherit those attributes and does nothing. Then other times it can inherit that attribute and also declares its own attribute, meaning it can modify it can add to the attribute rather, not modify it. So we'll look at examples here. We have this is fruit. We have the comment, we have the definition function, or we have a function here, which is a constructor, and we have name and amount as the data we are expecting. And we say fruit one, okay, do this. So we pass in mango and 15. And then we want to inherit what the fruit is having. So all we simply do, we use the pass keyword to inherit everything in the fruit class. So you do this. So when you do that, you can now use the new fruit to print out the new fruit, which is a class here, having the same attribute, which is name and amount. So by doing that, you can just pass in, declare a new object. So what I am saying basically here is that we have a class here, fruit. And in this class, we can have a method, mango, and the amount for the mango, maybe 15. I don't know the currency, so let's say 15. Then we pass it in. And then this is just to show an example. Okay, we can just say, okay, after doing that, we can just print fruit one dot maybe name. So this is just an example that, okay, we have a class and we pass in, we have an object for that class. So we print the name of the attributes. Having done that, we now said, okay, we want to inherit the same attributes for another class. So this is now the parent class and this is the child class. However, we are using the keyword pass. Why? Because we are not adding a new feature. So we are using the name and amount. We are not adding another variable or another parameter to it. So we just use the pass keyword and then we do this. And then we declare another object and use the new class we have defined, which inherits from the parent class. So this is the new class or the child class. It inherits the attributes of the parent class, which is name and amount. So we just come here, declare a new object, and then print it out. So how about we change it a little? Now we want to have, we don't want to just pick the attributes. We want to add our own feature to it. So we pick the name, the amount, and the quantity. We are now adding quantity to it. So we still do the same thing. We put the name of the class here, we pass it in. That's the parent class. And then the new class we define, which is new fruits one, is here. So we now had a function declared. Now for this function, we have a super. The essence of this super is for us to be able to pick the attribute of the parent class, which is name and amount. Why is this important? Is because we are going to make some adjustment. So we are adding a new feature to it. Else, we'll not need all of this. We'll have just put the pass keyword and everything is fine. So when we put the quantity, we have to do as we have repeatedly done, to refer to it and to store whatever is coming for it at the quantity, at the QTY variable. So we just do this and we are all fine. So we just go here. Initially, we pass in two parameters before, which is name and amount. Now we are doing name, amount, and quantity. So we try it, and this is what you get. So we can even say through dot name. Let's see. You see banana 3. So we can just print them out as we like. And then we can then make use of our intrinsic variable to see what happens to the object. You know, when we talk about intrinsic variable, we can pick the name of the object and pick this tick to just show what is stored in the object that we have defined. Let me show it. Okay, we are here, right? So we can just do this. Okay, we can just say the name of the object is fruit3 dot this the underscore. So we want to know the type of object and what is stored in it. So you can see everything that the object is passing. The name, banana for banana is stored. Remember dictionary, you have the key and then the value. So we have the amount and then we have the, which is the key, and then we have the value 6, quantity, which is the key, and then the value stored in quantity. So this is where intrinsic variable is important. In a situation, you may say you are looking at this, why do you have to now run this part of the code? Yes, it's important because ideally this is supposed to be in a different notebook. So you invoke it. So you don't know what is in that notebook. So you just want to know what have you passed to the notebook. You do this and it prints it out. And it is also recommended that when you are saving your notebook, which is going to be in .py format, you have to save it with the same name the class is. It's not for you to be able to identify, it's not for you to do anything special with it, but for you to be able to know that, okay, the name of the class, by looking at the notebook, you know that that is the class that is in the notebook. So when I say new fruit one, I will save it as new fruit one.py. That's basically what we are talking about. So when we now invoke it and use it for something else, and I said, okay, well, I need to know more about it, I can now use an intrinsic function to get more idea about the type of attributes that have been made use of on that class. So we can also talk about a rectangle example. The essence of having a rectangle example for it to work with area, perimeter, and volume of a rectangle. So first, in this case, we are going to use inheritance. But before we use inheritance, we'll first do a very simple example. Remember, we talked about multiple methods of function. So we have the class, and then we have the name of the class, rectangle. Oh, I have messed it up. Okay, we have the name of the class. So we now had this comment for the class. Then we have method or constructors, the one that handles the attributes, which is the data that we are going to be using, the width and the height. Then we now have the one that handles the area. What that basically does is to take the width and multiply it with the height, then returns it using the return keyword. Then we have another method here again called perimeter. The perimeter of a rectangle, well, is 2 multiplied by the width plus the height. So mathematics is here. What this does is just to return the data or the result. So we run it, and then we come here and said, okay, we call the class rectangle. Then we pass in our variables or our values, rather. We pass in our values. Then after that, we can now come and say, we'll call the object, which is area O. Then we'll now say dot, the name of the function inside the class that will perform the mathematical calculation for us, which is the area dot this. Don't forget about the curly brackets, they are very important. So we run this, and we have the value to be 30. We can adjust that and set 8 and 19. So we run it, and then we have 720 as the area. So basically what you see now is that after we have this class defined, we have like 3 different methods or functions in it. Then we now came here, we pass in some value to the class, which is instantiation of an object. We had an object here. Then we now point the object to the class and to the function that performs the area calculation, which is this function. So we point to it, and for it to refer to it, we use the dot notation to refer to it. So we had this as our result. Now, after doing that, we can now say, okay, how about we want to calculate the volume? Remember, we never captured volume here. There's no volume. So for we to do that, instead of it to start declaring the width, the height, all sort of that, no, we just inherit the width and the height from this class. We inherit the width and the height. Then we add volume, length to it so that we can get volume. So what we do is that we have rectangle V, which is rectangle volume. Then the name of the class above is what? Rectangle. So we pass it in, have it here, rectangle. Then we now have the 3 parameters which are important to us: width, height, and length. But do not forget the super keyword. It's going to help us to be able to make use of those attributes from the rectangle in the rectangle class above, which is this. So having done that, we can now define length. Then after length, we can now define a new class. And I said, okay, this class, you'll be the one to calculate the volume. So which is the multiplication of the width, the height, and the width. Oh, I put width again. All right, let me change it. It should be length. Okay, which is the length. And we just run it. That is it. So we come here, we declare an object. That object is going to be making use of the class rectangle V, and then we pass our 3 values to it. So once we've done that, we just pick the name of the object to make reference to the function here, volume, which is what you have here, using the dot notation, which is it. So by so doing, we run it and we have our solution. So we can have 32, 9, and then 1. So we have our solution. So basically that is all about classes and inheritance. I don't know, anyone who has more inputs or questions, feel free before we just take a look at the exercise here for you to work with for the next 2 weeks before we meet again. Hello?
I think you can go ahead, please.
Okay. So the exercise here is that we have to, how can we take outliers out of a data set? An outlier basically, let's say we have data that has, let's say we have temperature data, and the data normally you have it collected and it's within the range of 2 and 4 degrees. So the data can be 2.1, 2.5, 2.8, 2.0, it can be 4.0, it can be 3.9. And then you now have these values that fall into it, and the value is reading like 15, 20 degrees. Those huge values that are not within the range that we have defined, which is 2 to 4, those huge values are regarded as outliers. So because they will affect the statistics that will perform on the data. So if we are to maybe calculate the mean or the median, because of those huge values, you will not have the right or the correct mean and median. So your activity or your function now is to go and write the code using classes and functions to be able to remove outliers from such data set. So you're going to take input, the user is going to enter numeric values, and then you collect them, and then you go through it, you iterate over the data and remove the outliers and display the ones that are not, the ones that are within the range that we have set. So thank you very much for staying for this period. I hope you understood everything, and I also believe you are going to take your time and go through this class and understand it better. Feel free to contact me if you have any question about it, and do not hesitate to review our previous classes. Of course, we do have expectation. We are not just doing this to while away time, and our expectation